Chairman, ladies and gentlemen. It is my great pleasure to be here and to do some presentation for you about 3D printing, and especially the changing the trend of the 3D printing. And first, I kindly ask you to see a short video. Okay?
Take to help a business lower its costs.
So we were able to make changes that saved us at least $250,000 in total costs.
What does it take to help a little girl raise her arms?
She put her arms into the rinse, and for the first time, she was able to lift her hands up to her mouth.
Joyce.
What does it take to change the way everything is made, and thus shape people's lives? Shaping lives by revolutionizing the way things are made. That's 3D printing. That's Stratasys.
It's not an easy topic, and if you go out and you can see all the printers, and we can say that there are printers which are mainly produced for home usage, and there is another word which is produced for professional industrial application. I try to touch all the things, and there is one motivation or one engine which drives the whole thing, and this is the innovation. So I try to talk about some point of this, and I think we can skip the Varinex introduction, just to mention the left side, my friend George Volonch, and we founded the company in 24 years ago, so next year we will celebrate a nice event. Some milestones, which is an effect, that's no question about, that the first rapid prototyping service was established by Varinex exactly 17 years ago, and I'm still happy to do that. Because, you know, at the beginning everybody said that, George, you will be bankrupt, nobody wants to have any model created by layer, but today it is a little bit different. We have how many? 5 different machines, 4 different technologies, and I hope very soon, we will have a new machine which can create 3D metal models as well. So this is not very important, but everybody talks about the importance of innovation, and I did a little research and I got some nice sentences, and I don't agree with them, but I like to mention some of them. Innovation guarantees the freedom of the mentality. So just remember. But I think the innovation is a much more important thing, and in this year we celebrate the 15th years of the Innovation Prize, what we got. You know, I think all the gentlemen there, right side, Mr. Palinkas, who is now in English it's very complicated, but the head of the innovation office, and left side the Prime Minister, and it exactly was 15 years ago. So this was our first machine. It was about 1 ton, and it worked by paper, and layer by layer the paper was laminated by glue, and the hot roller, the Vashaló hanger you can see, is activated the glue, and the laser was cutting the actual contour of the given haze section. So it is really a fantastic, nice machine, still working at the Technical University and Economics at Budapest, but it's a little bit old-fashioned and a little bit slow. So, but anyway, it was really a good start, and we still love it. Why I'm mentioning innovation? Because innovation is a key moment in this whole changing the world, and there are several big categories, but probably the most important, and maybe it's very basic, but you have to remember that the innovation is such a process which process will realize a creative idea. So, but you have to have a creative idea. If you don't have that you are lost. And of course, there are several different categories. Main point, I think, for today is that if you want to have a new product, you need innovation, and which is very, very, very important that if somebody wants to have profit, it's a must to do innovation. And this is the guy, actually, Josef Schumpeter, I think, yes, Josef, and he wrote this in 1934. So it was not yesterday, and still in Hungary there is also an innovation law, and there are several things, but these are the basic things which you have to remember. Why 3D printing? This is an obvious question. There is a company, you will see in a minute the name, who collected the most important ideas and most important topics in the future, and there are altogether 12. I think somebody mentioned earlier, for example, the cloud technology. It's an important thing because everybody will use the cloud instead of a computer, and but which is very good for me, and it touched my heart. The 3D printing is in the 12 most important future element. And my personal opinion, according to my personal opinion, it's not on the ninth place, it should be a little bit earlier, but anyway, McKinsey says that the 12 most important includes 3D printing. And there are the 3D printing activity, there are two main fields. One field is the so-called personal printers, the small printers, what you can buy on a cheap price, and you can go home and you can print what you want. But the point is that I really have to be very careful not to say anything wrong, but these are not professional, I mean not industrial printers. You can print several things, and I think it is very, very important because for a child, children can have a very good toy to learn what is the layer by layer making something approach, and I think it is important because if somebody really wants to understand the 3D printing, it is probably the most difficult point that an object can be printed layer by layer. So all the engineers in my age, or let's say around 40, 50, every engineer has learned how to take off the unnecessary material, let's say by CNC milling or whatever, but to create something which is created by layer, it's a completely different story. Still, there are some, how is it called, social, financial solution like Kickstarter. Maybe you cannot read it, but here you can promise that you will create a new printer and it will be the best of the world, like this one. And if you do it very well, this marketing, you can collect $3 million. But still, at the right side, you can see even the projector can show it that this layer by layer approach, sometimes the surface quality and the total quality of a model can be a question. But still, we have to think about, because in 1 quarter, 3 months, about 40,000 printers are sold worldwide. So we cannot say that we need not to think about. It has to be think about, but thank God, I mean, for the professionals or the industrial guys, these are not the topic what we have to really concentrate. Why it is important, the 3D printing? First of all, as I mentioned, the innovation. What can a 3D printer innovate, or what can change? The first issue is the communication. Today, as you can see, I'm doing presentation with PowerPoint, but during a real technical meeting in a company like Bosch or any big one, they don't do it anymore. They print the model, what they have developed yesterday, and they put it on the table, and all the engineers sit next to the table, and they are talking the different features and benefits and all kinds of things, and they don't use any paper 2D drawings and PowerPoint. They print a model, and the communication is much better. The productivity of the communication is much better. This is also a sample, actually two samples, an engine block, very, very complicated part. If you really want to talk about, it is much better if you have it in your hand. And this is the left side is a top secret picture, so close your eyes, because this is an Audi engine in Győr, but they really use it daily to communicate. You know, in Audi in Győr, they do the assembly of the whole engine, and one assembly line is about 150 meters. So it's a very complicated mechanical engineering issue, and there are a lot of questions where to change the position of the motor block or engine block, and so it is much, much more easy to touch even if it's not a 1-by-1 scale model, but let's say a half-size model, it is much, much more easy to design a 150 meter long assembly line using this. It's one moment that about 20%, 27% of the 3D printers are used for better communication, which is really, really an important number. I just wanted to bring another sample like this. This is a part which must be injection molded. I don't know who knows what is injection molding, but this would be a real challenge to design the injection molding tool. And to talk about, it's much more easy if I can take the part which the injection mold tool will produce. I can hold it in my hand before I started doing the tool. So these are such a completely change in the world, I mean using the 3D printer world, that you have to consider. Of course, the second step is that you can print not only 1 or 2 prototypes, but you can print the first 100, 200, 300 models. Left side you can see such a technology which is called the selective laser sintering. In this case, thermoplastic, the normal thermoplastic material which is normally used in injection molding, is melted together by a laser, so all the functional tests can be done by these models, because the material of the prototype or the first small series is completely the same. Of course, there are several application areas where you can use 3D printed models. This is a short sample how we can create very fast sand casting patterns, core boxes, all kinds of things. And when an aluminum casted prototype is needed, earlier it took about 2.5 months. This time can be reduced about 1 or 2 weeks maximum. And of course, the big companies who is using these prototypes, they are really appreciate if we can reduce the time such a high level. This is also an interesting point. I saw one of the colleagues will do some presentation about, but this is the so-called topological optimization. The criteria of the optimization is to reduce the weight of the given model or given part. And this is how it is done. And you see from this shape, let's say the left side shape, you can find such a structured model. And the goal is to reduce the weight, and it is really, really important. But if you do it and you will get this model, then comes the next question, how it is possible to make it. Because, for example, do it by, let's say, investment casting technology, it would be very, very complicated. But if it's another sample, this was the conventional design of a bracket. Yes, bracket, and this is the right side, the optimized, topological optimized version, but it is simply impossible to make it. But if we have a right technology, the direct metal laser sintering, then you can do it by layer, whether it's steel or it is titanium, it's not a problem. This is the shape again. It's really nice, I mean, from mechanical engineering point of view, but it is simply impossible to produce it in a productive way using the traditional technologies. This is the first Hungarian sample what we did together in Győr. You can imagine it's also a part of the Audi engine, so you know who is the background. And it's interesting because we did some ideas, and I just show you. This is a kind of working envelope where you can put together 65 pieces. It means that in one shot you can do it 65 pieces, such a complex geometry, which is otherwise, other way, it's very complicated. It took about 20 hours. Everybody said, oh, 20 hours, it's long. But I think it is not so long because you need not to go to the investment casting. You can go directly, and from the 3D CAD file you can print directly what you need. And supposing some moment that that you have a machine, it's an EOS machine, and you can print 20 hours 65 pieces, and this is the bad news, such a machine is 700,000 euro, so take your pocket money, so you have to work on it. But this is, I hope you will understand, if there is a depreciation year, 7 years, then, and of course it costs 100,000 euro in a year. And if you multiply all the things, you can make in a year 20,000 pieces. And it means that one piece cost, I mean the depreciation, amortization cost is about 5 euro. Such a small amount that everybody starts thinking how it is possible to collect the 700,000 euro to start this whole thing. Okay, so there is an very, very nice story, and this is what will change the whole approach of the 3D printing. There is in the GE Aviation in the United States, they create gas turbines, and there are some nozzles, around 19 nozzles, pair nozzles. These nozzles take care about the gasoline, not the gasoline, how is it called, some benzene, whatever. So the fuel, and the fuel must go into the gas turbine, and the area which the first area, it's the most hot area, the hottest area, and it is 1,650 Celsius degrees. So a turbine blade must be a very, very complicated engineering topic. But this is also a topic, but the main topic here, to create the nozzle. Earlier, GE created the nozzle such a way that 20 different pieces was made with the traditional methods, and then they assembled, welded, and all kinds of things. It was a disaster, and now they are down. You can see it is laser sintered in one piece. And the productivity and the quality is no question. So GE in US, they purchased some machines. It is 80 machines, 80, not 18, not 8, 80. And you remember one costed about 700,000 euro, so it was a nice investment. But the 3 and the 5 billion US dollar, this is a total cost of the development, because they really want to create these nozzles and turbine blade in a completely different way. So they will develop new materials which can be laser sintered in the machine. So of course they do this the blade as well. Inside there are curvy tubes, curvy channels, I would say. Okay, sorry, I finish in a second, but this is so nice. So it means that inside they can cool the blade, and this is such a very important point. So of course there are several other issues and benefits of the direct digital manufacturing, which is also the name of the 3D printing. You can integrate those parts which were earlier injection molded separately, and this is also very important. The conformal cooling, which means you can create spiral holes, which is impossible to make it because there is no such a drill. So this is really, really an important point. But I think I have to finish it because the time is over, which I really would like to emphasize that we have a little showroom at the corner, and take one little piece because on 29th of October we will have a big conference on 3D printing, and you are all welcome. Thank you very much indeed.
It's very interesting to see 3D engineering,
Very good question. The metal printers, the EOS, we like EOS very much because they invented actually the metal laser sintering. There are a lot of companies who are copying, and there are companies who are paying for license fee. There are some companies who does not pay. No, but anyway, so the resolution is the layer thickness, the minimum layer thickness is 20 micron, so 0.02. And the XY accuracy is about 0.05 millimeter. I'm sorry to say, but it's very difficult to give you a resolution number because there is no. So no, because we could start talking about the similarity of the pixel. We could start talking about in the 3D version the voxel. But because the laser melts completely the metal, the voxel cannot be recognized on a printed part. No, the question was not, I don't know whether everybody heard it. What other elements are contained or consisted in the metal powder? No, it is metal powder. So today, as far as I know, there is no any ceramic powders, nano powders, not even. But I think the future will generate this. I mean, will answer this question. But today you can sinter different metals according to the standard metal descriptions. So if you choose the German standard, you can choose a specific metal, and it's possible to get that power there, and then you can laser sinter it. There are several models outside, so please come and touch. You already saw. Excellent.
Small question for you, if I may. Do you have any cooperation with, or ongoing cooperation, or planned cooperation with the tissue engineers?
No. Very short. A long question, short answer. The tissue engineering is such, you saw the earlier presentation, which was really high-level scientific thing. This is a little bit different story. So we mainly concentrate on mechanical engineering area, but because the time was too short, I had no chance to mention the medical approach or medical applications, because if we have such a machine and we can laser sinter titanium, specific titanium metal, we directly can print, let's say, individual implants for bone reconstruction and all kind of things. So there are so many medical applications, but I think Sanyi will talk about some words also. And next time, I think I will do another presentation about all the medical applications, okay? No, one more question. No, two questions. Oh. A little bit. Okay, I will repeat it. Yes.
Can the machine work with ceramic materials?
Which one? This EOS machine, not. The short question, not. No, I tell you how it is solved in the world, the ceramic, because the ceramic is an important thing. For example, the ceramic piece reconstruction when you need a complete bridge, whatever. Ceramic is mixed together some resin, which is a kind of matrix, and the ceramic is just a part of this whole mixture, let's say. And this can be printed, or using stereolithography, SLA, you can create 3D models from CAD data. And then you have to fire out the resin, and then you will get the so-called brown part. When you take out, this is the green part. When you, it's well, indirect. So after when you burn out the matrix material, you have a kind of porous something, and you have to put it into a sintering oven, and then you can get the final part. But there is no any other way to create ceramic. No, tessék szívesen.
Alfred, there are no questions because they have
Okay. But personally, I will answer, okay? Promise. Thank you very much indeed.